Imagine you are walking across a wooden plank over a creek. When you stand right in the middle, the wood sags down under your weight. In engineering, the bending is called deflection. Engineers have to know exactly how much that bridge will bend so it doesn't break. To figure it out, they use algebra. But when they first set up the math, the equation is usually a giant, messy pile of numbers and letters. This is where factoring comes to the rescue. Factoring is like organizing a messy room. It takes a big, confusing math problem and turns it into neat, simple parts. Why do engineers do this? Because factoring separates the problem into easy pieces. The outside piece might tell the engineer about the wood itself, like how stiff or heavy it is. The inside piece tells them about the geometry, like exactly where you are standing on the bridge. By factoring out the common pieces, engineers don't have to start from scratch every time. If they want to build the same bridge out of steel instead of wood, they just swap out one piece of the factored math. Factoring helps us break complex real-world problems down into the most basic building blocks. Today, we are going to learn how to find those basic parts. Grab your notebooks and let's dive. Let's start with regular numbers. A number written as a product of prime factor is in its prime factor form. For example, the prime factor form of 110 is 2 times 5 times 11. Similarly, algebraic expressions can be written as a product of their factors. The process of writing an algebraic expression as a product of its factor is called factorization. You already know how to expand brackets, like turning 8 times c plus 4 into 8c plus 32. Factorizing is just the reverse process. How do we go from an expression without brackets back to one with brackets? When you factorize, you take the highest common factor, the HCF, and put it outside the brackets. The leftover factors 1 and 4 drop straight inside the brackets. Let's look at taking out a number. What is the biggest number that divides both terms in 3y minus 12? The HCF is 3. We put 3 outside, divide both terms and put the result inside. 3 times y minus 4. What if the same letter appears in the terms? Let's look at m squared minus 3m. Here we can extract m as a common factor to get m times m minus 3. Sometimes you can take out a number and a letter. Take 5p plus 15pq. The HCF is 5p. Remember, 1 is a factor of every term. So 5p divided by 5p leaves us with 1. We put 1 and 3q inside the brackets, giving us our final answer, 5p times 1 plus 3q. Let's look at a common mistake. Leo factorizes 16mx minus 40my plus 8m like this. 2m times 8x minus 20y plus 4. Is it complete? No. There is still a common factor of 4 inside the brackets. To factorize fully, the expression inside the brackets must be irreducible. The true highest common factor is 8m. The correct working is 8m times 2x minus 5y plus 1. Now there is no common factor left inside. The factorization is complete. Now it's your turn. Try to factorize these 4 expressions fully. Pause the video, grab some papers, and I will reveal the answers. Let's see how you did. For the first one, the answer is 5 times 3a minus 4. For the second one, the answer is k times k plus 7. For number 3, the answer is 7x times 2y minus 3. And for the final challenge, the answer is 9p times 2p plus 3q minus 1. Great job today. To learn more, visit funmathsacademy.com.